Okay, algebra students, today is a lesson on functions. So write down this title, topic 5.3, functions. A function can be a rule. So write this down. A function can be in a rule. A rule is basically an equation. So a rule is an equation that has two variables. A rule is an equation with two variables. Okay, so a function can be a rule, and a rule is an equation with two variables, such as y equals 2x plus 1. So that's an example of a rule or a function. It has two variables, y and x. Okay, so a function can be a rule with an input, and the input we talked about is the domain. So a function can be a rule with input values, that's the domain, and then it has output values, and that is the range. So the domain is your input, and the range is your output. And here's an example of a function machine. So do your best to draw this in your notes. Here's a function machine, and this is used often to refer to functions. So this is example 1. So for example 1, you have a domain. Domain is your input. And you're going to take these numbers and you're going to put them into your function machine. This is a function machine. And that function machine is going to take those numbers and apply it to its function. And the function is y equals 2x plus 3. So this is your function, your rule. And then it's going to come up with an output. So for the first one, let's say you take this -1 and input it into your function machine. So you're going to replace the x with a -1, that's your first input. And then you're going to apply this rule and you're going to get a y, which is your output. So 2 times -1, -2 plus 3, you're going to get 1. So that's your first output, that's your range. Then we do the same thing with 0, and we put it into your function machine and replace the x with the 0. 2 times 0 is 0, then I add 3 to that, I get my y, and my y is going to be 0 plus 3, which is 3. So my output, whenever x is 0, is going to be 3. The last one is inputting this 1 into your rule. Again, your rule is 2x plus 3. There's your rule. So 2 times the 1, my input, plus 3 is going to give you my y, and the y is going to be equal to 5 in this case. So this is how a function works. So you get input, which is your domain, and then output, which is your range. Make sure all of this is in your notes. Okay, and to finish this off, what you end up getting when you are finished with your function machine is you basically get ordered pairs. So your ordered pairs that you got from this function were, you got, when you inputted a -1, you got a value of 1. Sorry, this is kind of messy. So that's your ordered pair. And then when you inputted a 0, you got a 3. So that's that ordered pair. And then when you put 1 into the function, you got the 5. So you end up with an ordered pair or ordered pairs that represent this function. Because a function can be represented with an equation, with ordered pairs, with a table, and with a graph. Okay, so now I want to introduce you to another topic or another word, and that is function notation. So write that down, function notation. Function notation is a way of writing a function, and instead of writing this as y equals 2x plus 3, we replace the y with what we call f of x. Function of x is what that stands for. So it's just a fancy way or just another way of saying y. So when you see f of x, all I'm doing is replacing the y with function notation, which means function of x. All right, so if I wanted to find f of negative 1, the function of negative 1, all I'm going to do is replace the x in the rule with a negative 1. Let me show you how this works. So example number 2, write this problem down. You have f of x is equal to x squared minus 3. And it tells you the capital D, that's the domain, is equal to negative 2, 0, 2, and 4. So what I'm going to do, I need to find the range of the function given the domain. So I'm going to substitute each of these values of D, the domain, your input, into the function. So you need to show your work. So f of x, I replace the x with the negative 2. So f of negative 2, so the function when x is negative 2, and then I replace the negative 2 into the rule, and then I get a range or my output. So I would get negative 2 squared, which is negative 2 times negative 2 is 4, minus 3, and so I would get 1. So my first range value is 1. If I do f of 0, that's the next domain, I replace the x with 0, 0 squared minus 3, which would just give me a negative 3. And then f of 2, so I do the same thing for each of these. So f of 2, and I get 1. And then f of 4, function of 4, put the 4 in there, and that's 16 minus 3, which would give me 13. So then we would say that the range, which is capital R, is equal to, and you put a brace at the end, and then you list your range. And we don't repeat because the 1 repeats, so I would just list negative 3, 1, and 13. And that would be the range. So the ordered pairs that you would get from this function also would be, first you start with negative 2. What did you get as your output for negative 2? You got 1, so that's an ordered pair. And then what did you get when you put 0 in? 0, you got negative 3. And then when you put in 2, and then when you put in 4. So these ordered pairs also represent that function. All right, let's try another one. All right, so write this problem down in your notes. Now you'll notice something a little different is that instead of using F, they're using G. And sometimes they'll do that. It's still the exact same thing. You're taking the G of X, and it's the same thing as Y. So G of X is equal to negative 2 times X minus 4. And they give you the domain. And our job is to find the range. So again, this is pretty simple. I just take the X, where I see X, and I replace it with each of the domain values. So negative 4, and then I would substitute. So negative 2 times a negative 4, that's going to give me a positive 8 minus 4, which I get 4. Now I'm going to do the next one. And just put it where this X is right here, I'm just substituting the value. So on this one I get negative 2 times negative 1, that's positive 2 minus 4 gives me negative 2. Then negative 2 times positive 2 is negative 4 minus 4. Remember to keep change, and you get negative 8. Then negative 2 times 6 is negative 12 minus 4. Keep change, and you get negative 16. So my range, capital R, is equal to, and the brace on the end, and then you list your range. 4, negative 2, negative 8, and negative 16. And again, the ordered pairs that are represented by this function, negative 4 plus positive 4, negative 1, and negative 2, and then 2, negative 8, and 6, negative 16. Okay, so let's go on and do example 4. It'll be slightly different. Okay, so it says for example 4, this is a little different, find the values indicated. So write down this problem. For h equals, and you have a list of ordered pairs. Okay, so we're going to find the value. What this means is you don't have a rule here. There's no rule. You have h of 6. So remember, this is your x. So that means your x is 6. So it's asking you to find y, find the value when h is 6, when x is 6. Now remember, ordered pairs are listed this way, x and y. So where in this list would x be 6? X would be 6 right here. So when x is 6, then your y would be 12. Same thing here. So here, when x, h of negative 2, that means when x is negative 2, what is y? So if we look at the list, here we have x is negative 2, so then y is 6. On the last one, where is x going to be 8? And it would be here. This is where x is 8. Remember, x comes first. So that would be 14. So that one's slightly different. You don't have a rule. All you have is a list of ordered pairs. So let's go on to example 5. We have 8 examples altogether. All right, in these examples, write these down. You have f of x is equal to 2 minus 3x, and then you have g of x is equal to 2x squared minus 1. And it's asking you to find, for number 5, f of negative 2. So you're only going to work with the equation that has the f, not with the g for this one. So all you're going to do is replace the x with negative 2. So you have f of negative 2 is equal to 2 minus 3x. Now all you're going to do is replace the x with negative 2. So 2 minus 3 times negative 2, and you do the multiplication first. So negative 3 times negative 2 makes positive 6. So this becomes 2 plus 6, which is 8. So f of negative 2 is equal to 8. On number 2, you have a g problem, so g of x. So you're only going to work with the g problem, not the f problem. So g of x, so g of 5 is going to be equal to 2x squared minus 1. So all I do is substitute the x with the 5. So I take the 2 and then I put in the 5 squared minus 1. We do order of operations, which means I do the 5 squared first, which is 25. And then I multiply 2 times 25 and then subtract 1. So I should get 49. So that would be your answer for that one. Number 7 has basically 2 problems to it. You have f of 4, so you're going to use the first equation, the f of x, and then it has the, then it has the g of negative 1. So let's start with f of 4. So I take f and put it there, f of 4, and then I just substitute it. So this is 2 minus 12, which is negative 10. So negative 10, and then I do g of negative 1. So I take the 2 and then I put a negative 1 where the x is. And remember, I'm using this right here, minus 1. So I take negative 1 and square it. That gives me positive 1. So this is basically 2 times a positive 1 right here. Then I subtract 1. So 2 minus 1 is just 1. Now notice here that I'm adding these two together. So this is f of 4 plus g of negative 1. Well, f of 4 was negative 10. Then I'm going to add that to the answer when I get g of negative 1. So I'm going to add that to 1. So negative 10 plus 1 makes negative 9. Okay, so this is function notation. Function notation is just very similar to doing the y value in an equation. Y equals 2x plus whatever, and so this is just another way of showing it. All right, one more example. Okay, this is kind of a review example from the previous lesson. So here I have a line segment that you need to graph, so you'll get some graph paper and graph it, and we want to find the domain and the range. All right, when you graph it, you'll have a line segment that begins at negative 3, 5 and ends here at 3, negative 3. Notice that this is an open circle and this is a closed circle. So what we do is we look at our x values. Remember, this is our x. All right, so x, you have a negative 3. That's your domain. Your x values are your domain. And then here you have a positive 3. So you look at your two x values, negative 3 and positive 3, and write those down. Your x is going to be in between those two. All right, then since you have a closed circle here, that means you're going to use the greater than or equal to symbol. So remember, as x goes this way, it gets greater than negative 3, and it goes all the way up to 3 right here. So these are your x values. Okay, and it's going from left to right, which means it's getting bigger. So the symbol that you would use at the other end where this is a less than symbol. So not equal to, just less than. So the way you read this is x is greater than or equal to a negative 3, but less than a positive 3. All right, let's try the range. So range is going to be your y values. Remember, this is a y. So your y is 5 and your y is negative 3. So you can start with the lower value first. So negative 3 is smaller. So I'll put the negative 3 here. And then there's your 5. So I put the 5 there. And your y value is in between those. And again, you just have to figure out what kind of symbol to put in between. So your y values go all the way from negative 3 all the way up to 5. So remember, as it goes up, it gets bigger. So y is going to be greater than a negative 3, but remember it's right here. It's not equal to because of that open circle. And then it's going to be less than or equal to 5 because you have a closed circle right here. Okay, so that's how we do that. That's a review. I know that domain and range can be sometimes difficult for students, so if you're not quite understanding it, I will certainly help you and go over it. Just make sure you ask. All right, so do a whisk on this. When and where did you watch it? Summarize what you've learned about function notation, domain and range, all of that in this particular video. And then what questions did you have? Write that down. All right, thanks for watching.